Question 9. This question is about displacement reactions. Iron is extracted from iron oxide by a displacement reaction with carbon. The equation for the reaction is iron 3 oxide. The 3 goes there, that's plus 3, and the 2 goes there, that's minus 2. So that's 3 carbon. Carbon is 0 oxidation. 2 iron. Iron is 0 oxidation. Any element on its own have 0 oxidation, and that's 3 carbon monoxide. Stoichiometric mole of iron 3 oxide is 1. There's 1 here. Stoichiometric mole of carbon is 3. Stoichiometric mole of iron is 2. And stoichiometric mole is 3. It means that the iron has lost its oxygen to carbon, so that's reduction, and carbon has gained oxygen from iron to form carbon monoxide, that's oxidation. So this is oxidation and that's reduction. 9.1. Which substance in the equation is reduced? Give one reason for your answer. Answer in terms of oxygen. So we know that that oxidation state here is plus 3 and minus 2, and iron is now 0 oxidation state, and therefore, but in terms of oxygen, we need to say which is reduced. Well, iron lost its oxygen, so iron 3 oxide is reduced to iron. And the reason for that is loss of oxygen. This is lost its oxygen to carbon. Question 9.2. Which expression shows how to calculate the mass of carbon needed to produce 1 mole of iron from iron oxide? The relative atomic mass of carbon is 12 grams per mole. The unit is missing. So in this case, we need to write down the equation again to help us to know what we're doing here. So this is the equation. As you can see, this is 1 mole of iron 3 oxide is producing 2 mole of iron, but we need 1 mole of iron, so that's what they're telling us. The stoichiometric mole has to be 1 mole. So what can we do? We have to divide everything by 2. If we divide everything by 2, that becomes 1 mole. I'm going to pick this first because I'm looking at this one in terms of carbon. So I'm going to just look at these two. That's what they're asking us to do, and divide it by 2. So I'm dividing everything by 2, so I divide everything by 2, but I'm only looking at these 2 here. So now I've got iron. For every 1 iron, I get 3/2 of carbon. But carbon is 12 grams per mole, so I'm going to get here 3/2 times 12 grams per mole. And this is our 3/2 times 12 grams per mole, which is for that one. The answer is going to be that. A student investigated displacement reactions of 4 different metals represented by A, B, C, and D. A, B, C, and D are not the actual chemical symbols for the metals. The student added each metal to aqueous solution of the metal nitrates. Observed whether a reaction took place. Table 6 shows information about 3 of the reaction mixture. This is metal A reacting with B nitrate. The A is going to kick out the nitrate from B, and B will lose its nitrate. So A higher reactivity series than B. That's why A kick out nitrate from B and stole it. But we got 2 nitrate for every 1 A, which means A is 2 plus, so A must be group 2, and you got the nitrate, which is minus 1. So this will be 2 plus, and there's a 1 here. You can't see it, but there's a 1 here, and that's minus 1 for that, because that 1 goes to there, becomes minus, and this 2 goes to there, it becomes plus. So A is group 2 metal. C reacts with A, and now C is kicking out the nitrate from A, which means C is higher than A in the reactivity series. How many C is reacting with the nitrate? 3 nitrates for every 1 C. So there's a 1 here, 1 C, and that's 3 nitrates there. So the 3 goes there, plus 3, 1 goes there, minus 1. So C is group 3 metal, like aluminium. A will be like calcium or magnesium. C is group 3, like aluminium or boron. C then react with D nitrate, but D is higher than C, therefore C could not kick out the nitrate from D. So D is more reactive than C. 9.3. The ionic equation for reaction 1 is A plus 2B plus minus 2B plus A2 plus, which means A is losing electron and B plus is gaining the electrons. This is what we're having. A is losing electron to become 2 electrons to become A2 plus. That's oxidation of A. A has been oxidized from 0 to 2 plus. And B, 2 plus, is gaining the 2 electrons because you need, B only need 1 electron, is B plus. But we have 2 B's, so we need 2 electrons to compensate for the 2 B's, and that's 2B0. The B plus is gaining the electron to become B. So we have a redox here. Why is this a redox reaction? Because we have oxidation of A and reduction of B plus. So we say A loses electrons and B gains electrons. And so we would have that as the answer. 9.4. Which of the 4 metals has the greatest tendency to form positive ions? You saw the metals there that if we go back here, D has the tendency to stay here. D will not lose its nitrate. So that means we're going to have D 2 plus and nitrate minus. And that is what we're going to get. It's going to be D. So we would say D. Question 9.5. The nitrate ions has the formula NO3 minus. That minus is for the whole thing. Which of the 4 metals could be aluminum? We've already explained that earlier because we said the C has 3 nitrates. So therefore, because it's got 3 nitrate, there's a 3 here. That 3 goes there, that'll be 3C3 plus. And the 1 here, we go to nitrates minus 1. So because it's C3 plus, that must be aluminum. So it's got to be metal C. And the explanation for that is what we said. Aluminum forms ions with a 3 plus because aluminum is in group 3. 3 nitrate ions are required for every 1 aluminum ion. So the plus 3 here is referring to group 3. Question 9.6. Metal X is extracted from an oxide of metal X by reaction with hydrogen. That means hydrogen gas. The equation for the reaction is XO3 plus 3H2 to give X plus 3H2O. The percentage atom economy for obtaining metal X by this method is 77.3%. Calculate the relative atomic mass of metal X. While the relative atomic mass of hydrogen is 1 grams per mole, oxygen is 16 grams per mole. The water here will be 3 times 18 grams per mole, and that's the relative atomic mass of X. So because we got 3 waters, stoichiometric mole is 3, that's 3 waters, so we are going to be getting 54 grams per mole. And so the percentage atom economy here, we can say is going to be what we got here, ARX, which is that one, ARX, which is on top, divided by the total of what we got here. So it's that one that we're looking for over the total of what we have for the product. So ARX divided by ARX plus 54, and that's 54 is coming from water. 3 waters. We times it by 100 because it's percentage equal to 77.3 for the X we're talking about here. So that equals to 77.3. So all we need to do now is simplify and find X. So I'm going to multiply ARX plus 54 by 77.3. That's ARX times 100 equals to 77.3 times ARX plus 54. And we're going to expand that. And then we take this one here to the other side to collect the like terms, and we get that for that. So this is that one here. Factorize that to get ARX equal to. So when we factorize that, 77.3 minus 100 is this one times ARX, and that equals to this. We need to divide everything by 22.7, and we get the relative atomic mass of X, which turn out to be 183.885 ... grams per mole. And so we can keep it at 3 significant figures, 184 grams per mole. And that'll be the answer to that.